Okay, EOC cram notes. So we're hitting it all as fast as possible with some doodly stuff around the outside, so in case I get windy, because you guys know how I can do about talking a lot. So entertain yourself with coloring, but also get your notes done. This is going to be like math 3 at a glance with lots of colors is my plan. So we can dig up all the old stuff we've learned so we remember what could possibly come at us on our EOC. So converting from log to exponential. The reason you are converting from log to exponential or exponential to log is if the x is in the basement or in the attic, for lack of a better word, so in the base or in the exponent, you can't solve it in those two places. So switching it to the other form allows you to use your calculator to solve. So going from log to exponential, we're going to grab our base, start there, go grab our exponent, and swing out with our lowercase cursive e, because we're going to exponent, with our output. So we started at the base, we went and grabbed our exponent, and then we scooped it out with our output. So in exponential form, that means we're going to have x to the second power equals 7. And this is where we would take the square root of x to find out what that 7, or the x is, the square root of x squared and the square root of 7. And remember, every time, this does not necessarily pertain here, but every time you take the square root of x or the square root of any number, you are going to have a positive and a negative. And then you just have to decide which one is the most relative, like which one works for the conversation. Obviously, if it's distance, you don't want to do negative. If it's just algebraic, both answers are perfectly acceptable and usable. So you want to make sure, remember, every time you take the square root, you have two answers. So from here, we use Desmos. So you can type this in just as so. And if this was log base 2 of 7 equals 2 or log base 8 of 7 equals 2, in Desmos, you don't have that problem. In a TI-83 or 84 or any of those 82s, not all of them have the update where you can put whatever base you want. So in that case, you're going to use a change of base. So whoever was in the basement stays in the basement. Whoever's online stays upstairs. And that is equal to 2. And that log base nothing 7 is log base 10. So 10 is your imaginary number. When there's not a base, it is a log base 10. So this would be like 10 is raised to something to get 7 if that was just one line. But because it is division, if this was a number, when you type that in your calculator, it will give you an answer, like a numerical answer, so you could keep moving. Now going from exponential to log. So from exponential to log, we're going to push it, the base down into the basement, go grab our output, and then equal exponent. So this is our exponent this time. We're going to shove the base into the basement. And then this is our output. So it's going to be log base 3, because that is what's in the base. Output is equal to exponent, x minus 2. Now, again, we're using Desmos, so you can type in log base 3 of 27 and get a numerical answer and then solve for x, because that would be what you would do here. But if you were doing change of base, again, just in case you're ever on a TI-83, so ACT, SAT, all that fun stuff, whoever's in the basement stays in the basement. Whoever's online stays at top. So basement stays in the basement. Log 27 divided by log base 10 of 3. Now, remember that log 3 of 27 is, what number is 3 raised to give me 27 is the question that's being asked. So this is the same thing this is asking. So log base 10 of 27 divided by log base 10 of 3 is figuring out what number did I raise 3 to get to 27. In this case, it is 3. So 3 cubed would give me 27, so I can have a 3 here. I'm going to add 2 to both sides, and x is going to equal 5. So 5 minus 2 would give me 3, so 3 to the third power does give me 27. So this one you might be able to logic out. It's fairly easy, but I wanted you to be able to see where the parts sort of tied together. So chose easier numbers on purpose. So remember, you're going to have to convert these when the x is in the basement or in the attic. So not straight line portion of your equation, reading straight across. All right, moving right along down to transformations, everyone's favorite. So again, not doing any practice problems, just remembering a lot of the things. So this is an exponential. So we have a base of 2 raised to the x minus. This is where your h is going to go. Then down on straight line is plus k. So k goes there. Now, the variables can change. This is just the variables we've learned. But it could be a, b, c, d, e, f, g, h, I, j, k, x, y, z. It doesn't matter. Whatever these are, it can't be an x or a y, sorry. But whatever these two are, it does not matter what variable they use or what variable they ask about. Like I think some of them had a k in this spot. If the k is in this spot being inside the parentheses, then this is going to control the left, right. So whatever is with the x is left, right. So that's your left, right slide. So horizontal, which makes sense because your x-axis is horizontal. Now, whatever's on the outside, so outside of the parentheses, and literally there would need to be parentheses. Maybe in the exponential, you may not see the parentheses just because it's going to be at a subscript, so up at the top. But if it's sitting on the outside, and this value could be in the front. If it's attached by addition or subtraction, this is your up, down. So your vertical change. So this is going to slide it left and right. This is going to slide it up and down. Your number in the front, this is your base. But there could be an A in the front of this one. And if it is greater than 1, then it is going to be a vertical stretch. So vertical stretch. If it is less than 1, so any fraction, then it's going to be a vertical compression. And compression, I always think of as a squish. And I always think of these, even though we're looking at an exponential here, the shape of a parabola to me makes a lot of sense, that if I vertically squished it, he would get very fat. It would slow down the rate of change, like his thinking linearly back to math 1, but he would slowly start coming out like this if I squished him down. And then if I grabbed him at the top and I pushed him up and pulled him up, he would start to get skinnier because that means he would increase faster. And again, I'm just using the parabola because I feel like visually for me it makes more sense. Sometimes your exponentials and your logs and all those other fun graphs don't show it quite as blatantly. But again, whatever's attached with the x by minus. Minus is the formula. So if there's a minus here, then that means it's going to move right. If there's a plus here, that means it moved left because that h value is negative. Now, looking at your log base 2, x minus h plus k, still controlling the same thing, still in parentheses versus outside of parentheses. So the same thing you're looking for. The pattern is the same. Quadratics. So this is just in a different, this is not in our standard form. But so then again, when it's raised to the second power, it's going to be the same as cubic as well. So there are going to be parentheses still around that x. And then there's an h value, which controls your left, right. And then a k value that controls your up, down. Now looking at this a value, that's less than 1. So it's going to be a vertical compression because it's on the outside. So this is quadratic because that 2, it's going to make that parabola a lot fatter, a little squishier and squattier because the rate of change is going to go slower than 1 versus where if it had been a 2, it would have gotten a lot skinnier again. Now, absolute value, the reason I circled this is, in my opinion, you're going to see more of your transformations and conversations with absolute value. So again, they're not parentheses, but it's the absolute value bars. If it's inside with the x, we're going left, right. Then if it's attached by addition or subtraction, usually on the right-hand side at the end, but it can be anywhere. If it's addition or subtraction, your k value is your up, down. Now, also, hk is your vertex. So hk is your vertex. Now, we were talking about how they're a little different if it looks different. So if I had x plus 4 minus 2, that plus 4 means my vertex is going to be negative 4, negative 2. Now, if it had been x minus 3 plus 2, then that's going to be a positive 3, positive 2. The guys on the outside, your k value, your up, down, does react exactly the way your gut would tell you to. When it says minus 2, it goes down. When it says plus 2, it goes up. Inside the parentheses or inside the absolute value bar, it goes what I would call opposite of what my gut says. Because plus 4 you think would go to the right. But because of that minus, that means I actually plugged in a negative 4 here. And minus 3, most of us would think goes to the left, but I actually plugged in a positive 3 into that minus, and that's why it still exists. So remember, inside goes opposite of what you think. Outside reacts exactly the way you would think. All right, moving right along, growth and decay. It was a quick unit. So hopefully remember this because it was in Math 1 as well. So A, this is how many rabbits, bacterias, how many zombies. So you're starting them out, your initial value. So the starting number when you're about to start this test where we're tracking the growth or decay. So T is going to be our time. Usually in exponentials, back in like Math 1, this would have been an X. Again, the variable of choice is irrelevant. It's just that there is a variable there. And then your R is going to be your rate of change. Now, don't stop listening yet because here's the important part. This is where you guys usually will mess up because you get running. As a decimal. So if it's 37% growth, then we are going to add 0.37 to 1. If it's 2.5% growth, then we are going to add 0.025 to 1. So you're going to multiply it by, divide it by 100 or move the decimal 2 places to the left. But it is always 2 places because it is always relative to 100. So we're moving it 2 to the left or dividing by 100. All right, so coming over here, sometimes this is the way you see it a lot with word problems because you're going to have that 1. And that 1 actually just constitutes for the original amount. Because if you got rid of that, then this amount would not occur first. Okay, so then we have A, B, T. B is the same thing of 1 plus or minus R. So plus being growth, minus being decay. The difference is that it's already written combined. Instead of this being 1 plus 0.47, they wrote it already as 1.47. So knowing this is greater than or less than $1 is the way I keep it straight in my brain, is how I decide if it's growth or decay. So more than $1 is growth because that means we're gaining money. Less than $1 is going to be decay. So looking at this one, that is 47 cents more than $1. So that is a growth of 47%. So if I had for 1.32x, is that more or less than $1? In this case, it's more. So it's 0.32 more, which means it's 32% growth. Now, if I have, let's see, 47.73x in the ABT form or AB to the X form, is that inside the parentheses greater than $1 or less than $1? It's 73 cents. So it's less than $1. How much less? Because that's what you were doing here. It's more. How much more? 0.47. It's more. How much more? 0.32. In this case, how much less is 0.73 than $1? And that's 27 cents that we're missing. So that means it's a decay because it's less of 27%. This is where most of you will jump. Same in Math 1. Students do the exact same thing. Get real excited, take off running, and just assume that it's 0.73 growth, 73%. But again, it is a loss relative to $1. Usually if I can get you to think about money, you'll notice that loss or gain. All right, running on to page 2. So a big call out for everybody that you needed some review on formulas for volume. Biggest thing, height is the number of Post-it notes. Or like if you're slicing bread and making a sandwich, you want the bottom of your bread and the top of your bread to match. If you are pulling Post-it notes out of a stack, whether they be triangular, because this is going to be a triangular prism, that's our base because that's the shape we can continuously get repetitively. That is the same. So the height is how many of that shape can I get? So in this case, we can call this one a cube because this is a square. How many squares all the way up? Now, volume has to do with if this is, like I said, Post-it notes, I need to know the area of the first Post-it note. So this is a square, so that's length times width. Or you could call it side square. This is a triangle, so that's 1/2 base times height for the area of a triangle. Now, to solve for the volume of the prism, we want the area of the base and then how many are in the stack. So the way we learned it was big BH. Big B is whatever area formula is used relative to the shape of the base. So this would be volume equals 1/2 base times height of the triangle times height of the prism. So how many pieces of Post-it notes? How many papers? How many slices of cheese? Toblerone candy is what this reminds me of personally. But same thing here. So volume is going to equal length times width times height of the entire pyramid. I'm sorry, cubic prism. So again, how many square Post-it notes are in this stack? So volume equals big BH. If you can remember that, you will get through all of these, because as long as you know the area of the base shape and how to solve it. So moving right on to cylinder, theoretically, this is a prism with a circular base. The area of a circle is pi r squared. Pi r squared. And remember, radius is from the center to the outside. Diameter is from outside to outside, so all the way across. Make sure we don't mix up the two, because you only want to use radius for the area of the bottom. I like to think of this as either like a stack of bologna, because bologna is gross in my opinion, but it helps me remember how many pieces of bologna is going to be my height. So again, we're doing our height. How many stacks of bologna, or if this happens to be provolone cheese, is usually perfectly round too and in a stack. So how many slices of cheese, salami, I'm trying to think of all the things that are kind of shaped like this. So ultimately a cylinder is a soup can, but you want to think about how many slices go all the way up, because again, you probably learned the volume formula is pi r squared h. Pi r squared is your big B. So again, you're back to big B h. So you've learned all three of these formulas just knowing big BH. Now, we'll come back to spheres. Cone and pyramid. So looking at pyramid, so I always think about, I guess it's actually the cone that I think about when you go, or like in middle school or when you play sports and they have the Gatorade containers and they have the little white cone-shaped cups. Someone inevitably always drops it on the ground, it gets stepped on, and it looks like a triangle. So it becomes a flat figure of a triangle, which is three-sided. So it's been squished, and that three-sided, so we want to remember the number 3. So you either think of it that it gets squished and that it makes a triangle, or that pinch at the top, because this is a cylinder that we just pinched at the top. So we just took it and we tied it or twisted it so it had a pointy top and we could put our water in it. But again, you still have a circular base. We still have a straight up and down height, so you want to be careful, because this is your slant height. This is not the number you want to use if they give you the slant height. If they give you the slant height, you are likely to have the radius, and you would use Pythagorean theorem, because it is the right angle height, so straight up and down, that you want to use. So our height would be this guy here. Slant height, they will trick you in hopes of you using it, but you're going to use that as your hypotenuse, another measure of your leg. And maybe they give you the height and you need the radius, but you can pull out a perfect right triangle here and use Pythagorean theorem. See, if we're missing our radius, we get a squared plus b squared equals c squared to find that. So just don't let slant height sneak up on you. But back to volume. Pi r squared is the volume of this, of our circle. We know we got to do height because it's a three-dimensional figure, and we pinched it to make a triangle, which is a three-sided figure. So we divided by 3. So literally it's the same formula as your cylinder, but we pinched it, so we divided by 3. Looking at our pyramids, so we have a square base again, or maybe it's a rectangle. We're going to pretend like it's a square so it matches the one above it. Triangle. Area of a triangle is 1/2 base times height. Area of a square is length times width. Again, height is straight up. This would be your slant height, and you would again have to work a Pythagorean theorem style problem to find whichever you're missing. If you're missing the length on the side, you could get half of it. And if you had the height, or like, you wouldn't need that here, I'm sorry. You would have half this. So like if they said this is 2 and this is 2. Again, you could use that if they gave the slant height to find the vertical height. But we're going to pretend like they're giving to us all the things we need. So again, length times width times height. So just like our square prism, we pinched it at the top, so we're going to divide by 3. So same thing for our triangle. We have 1/2 base times height. That's our triangle area times the vertical height of our pyramid. We pinched at the top, so then we're going to divide by 3. So again, big BH divided by 3. Big BH divided by 3. Big BH divided by 3. So big BH and big BH divided by 3, you've just learned all of these formulas. The only one that I find in my brain that's a little harder to remember and takes a little more studying is your sphere. Now, it is a circle, so we can go ahead and be happy with pi r. We're going to divide by 3. There's no pinch here, but just hang there with me. Divide by 3. It is 4/3, not 1/3, so 4/3 r cubed, so not r squared. And I wrote this in a different color because that's how I learned to memorize when I was working on trying to figure this guy out, because those are the things that are different. Where you guys, most students will mess up when they're just running and they're nervous and they're all upset about all the things, or they didn't study, is 1/3 pi r squared is what they'll try. And that is going to give you your cone without the height. So it really is making up a formula altogether. But pi r cubed, 4/3. So 4/3 pi r cubed, or 4 pi r cubed divided by 3. The exact same thing. So that would be the volume of that entire sphere. Now we have a hemisphere, which is half a sphere. Same thing, you're going to use your radius. They often don't give you the diameter, so make sure you're paying attention. You're going to still do 4/3 pi r cubed, and then you're going to half it. Just divide that answer by 2 because it's half of your sphere. And a lot of people will get excited to get this done and forget to half it. So before you walk away, first when you look at your problem, this volume, discuss in your brain what shape it is. And then before you pull the trigger on your answer, again, double check what shape it is. Now, this is a trapezoid. We didn't do a lot of them in class, but it is a thing because you learned that area formula a long time ago. It could be a trapezoidal pyramid. It could be a trapezoidal prism. But remember, trapezoid is 1/2 base 1 plus base 2 times height. So that's your big B. And our height would be this guy. This would be base 1, base 2. So 1/2, the sum of the bases times the height. And then we are going to multiply that by the height of, if it was a prism, like if it became a volume. But 1/2, the sum of the bases times height is just going to be your area. So this would be your area. And then we would just multiply it by the number in the stack if it was a prism, and then divide by 3 if it happened to be pinched off at the top. I've not seen a lot of pyramids with a trapezoidal bottom, but they will sometimes give you a trapezoidal prism. But again, the 1/2 base 1 plus base 2 times the height gives you that area of this whole Trisha trapezoid here. So all of this guy, all the gray part. And that's what I got for volumes. Circles. Now we're not doing a lot of the changing. This is just remembering the parts. Again, keeping it short and simple and trying to throw out as much information as possible. So x minus h, y minus k squared equals radius squared. Now h is going to be your x value. K is your y value. R is your radius. And when we say the x and y value, we're talking about of the center of your circle. So it'll be at x and it will be at y, otherwise known as h. K is your center. So these two numbers are your center. Again, big call out to those minuses in there, because if they write it with a plus, the number that got plugged in there was actually negative. So same as our transformations. But x minus h squared plus y minus k squared equals radius squared. This is not the radius when they give you a number here. Remember, it's radius squared. So you have to square root it to find the actual length of radius. Now, look at all the other fun vocabulary words and things. This is a lot of stuff. Just vocabulary, though, not computations. Just vocabulary. So we have segments in a circle. So we know we need a center. So we'll call this C. And then from the center out is a radius. That's most of our like big does. We all know that one, right? And then we have the radius twice, which is our diameter, but it has to cross through the center. So mine's a little off because I want you to be able to see it relative to your radius. Then you have a secant, which means it crosses through twice. So that's our secant. Then we also have what we know as a chord, which doesn't cross through at all, but it does touch twice on the outside of the circle. So a chord touches outside of the circle twice. And again, this is just vocabulary to make sure you don't get a question written and you don't know what it's talking about. And then last but not least, we have tangent. And tangent means it's going to just brush, bump, and go. So bump and go. It's a drive-by. So it touches the outside one time. So that's going to be tangent. Now, these segments we were using for segment length in a triangle. In a circle. And so that were the two different ones. Well, there's actually three, but each segment type. So we had one that had 2 chords. So in this case, we have 2 chords. And they intersect inside the circle. And we're looking at the length of the segment. So we have X. Let's do X. And this line continues this way and finishes itself. And then our other line, we have 4 and 3. And not drawn to scale, obviously. I'm just throwing out numbers here. And when the 4 and 3, I'm color coding them. But what you need to remember is that it's this line and then the other entire line. And you're going to take each part, so 4 times 3, and set it equal to 10 times X. And then solve it. So in this case, not a nice, neat answer, but it's the continuation of that line. Those two segments are what's going to work. Then we also have a tangent line and then a secant. So it's going to cross through twice and stop. So secant, because it came all the way out here is why. Now, what I want to call out so you can see the patterns, again, less to memorize, the better. So this is on the outside and this is on the outside, right? Our tangent is down here. So this is our tangent. I'm going to call it X. And then our secant, let's do 4 and we'll do Y. So we can't actually solve it, just so you can see how they relate to each other. So on the outside, it's going to be times itself because there is just that one. So it'll be X times X, or better yet, X squared. And we're going to set that equal to the outside times the sum of the whole thing. So 4 plus Y. So outside times the sum, which is the same thing we did here, outside times the sum, but there is just the outside. So that's why it's X squared. So outside times the sum. So if there's an outside, outside times the whole length, outside times the whole length. In this case, like I said, tangent, it just repeats itself. Now, looking at angles in circles. So an inscribed angle, the vertex is on the circle. Vertex is on the circle. So if I'm going from B and working my way in, I'm going to half it. So this length of this section here, or degree measure of that section here, is going to half as it comes in to find this angle. Half as it comes in. If you go out, it doubles. So if you're working from the inner angle to know the angle of the outside, it is 2 times on the way out. Now, central angle, central, you hear the word center, so we need the center of our circle, and it's going to be an angle as such. Central angles, the vertex is on the center, so not on the outside, on the center. So that means they're the same. So A, if this is angle A and this is angle B, A is equal to B. So they are always going to be the same measure. So if this is 72, this is 72. If it's 112, this is 112. As long as the vertex is on the center. Whereas when the vertex is on the outside, it halves as it works in and doubles as it works out. Now, if I have segments, now we're talking about angles here. So this is angle on, this is angle outside. If we're solving for the angle outside, and that would be out here, this guy here. I'm going to take angle B and angle A, arc, the degree measure of arc B and the degree measure of arc A, and you're going to subtract them and then divide by 2. So B minus A, and then divide by 2, just like you did up here, because the angle was not in the center, so we divided by 2. So it'd be B divided by 2 equals A. So now it's B minus A, the difference of these two divided by 2 to get outside. Now on the inside, we're solving for these angles here. They are vertical angles. It's another good vocabulary word. So for a throwback, they are going to be congruent. We're going to take B, whichever one you want to call B, whichever side, and A. And I think about the fact that it makes an X inside the triangle, and an addition symbol is the closest to x, because not multiply. We're kind of pushing here. So b plus a. It does not cross through the center, so we have to divide by 2. So b plus a divided by 2 will give me these two angles. Then just for another vocabulary reminder, so this guy and this guy, linear pair, which means they equal 180. So if I can find this one, then I can subtract it from 180 and find this one. Or even this way is a linear pair, or maybe you could then use these as vertical angles. But you can answer lots of questions at that point. Now, arc length. So we're going to go from our center. Arc length is a portion of the circumference. So I like to think about food or money usually. So I'm going to think about pizza. So it's our pizza crust, this portion out here. So it's the pizza crust. It's just the crust of the circle. And crust is circumference. And circumference is 2 pi r. Now, 2 pi r, but we have a percentage, like a degree measure of the entire circle. A entire circle is 360. So whatever size slice, whatever angle measure this slice is, times it by the circumference, but divide it out of 360 because it's just that one pizza slice out of the whole pizza. Now, sector area, you said area. Hopefully we know area of a circle is pi r squared, so you want to keep that in mind. And again, this is the goodies. So this is the cheese and all the pepperonis and mushrooms or whatever you put on your pizza, onions or but whatever you put on your pizza, it's the good stuff, is the sector area. So it's the inside. So it's the area, but again, it's only a portion of this entire circle. So a portion of 360. So x, whatever degree measure this is, divided by 360. So again, your formula for area, your formula for circumference, and then it's the fraction of the entire circle. All right, guys, that's going to be it for these 2 pages. More videos coming soon.